All right, so today we're going to be talking about a piecewise function. So a piecewise function really does kind of go along with the name of it. It's where you take pieces of functions and you put them together to make a new function. So a piecewise function is where more than one formula is used to define the output over different pieces of the domain. So every piece that you are using, or every piece of a function that you're using, it's going to give you the domain of that function. So the first thing that I put up here is an example of how to graph the piecewise function in Desmos. So the biggest thing, you probably will not have to do this, but in the case where they give you a piecewise and you want to look at it graphically, you can, but a piecewise does not have to be graphed in order to evaluate it, which is what we're going to be doing in this class. But if you put it in a Desmos, all you do is you type the individual pieces. So if you look right here, I have each piece and you're going to separate it individually. Now the key is that in the piece, if you notice in my little graph here, that I've used the curly brackets, the set brackets, okay? It will not work if you don't use the set brackets, but you put it in there and then you use your set brackets and you put the domain that it gave you. So basically it's telling us, if you look at the red, so this whole function looked like this. So that's the whole function, but we only wanted a piece of that function. So we only wanted it where x was less than -1 for the x value. All right, the same thing for my next piece. So this one is in blue. Okay, so if you're looking at the blue function, you can see I use my set brackets. This function looked like this, but we only wanted the function from -1 to 2. So that's one piece of that function. And then, of course, the last one, we have just 5. So y equals 5, but we want it from where x is greater than. So this one was the entire piece right here, but we only wanted where x was greater than 2. So it starts here and it goes to infinity. Okay, so that's how you can look at it in Desmos. Again, it's just a matter of typing in each piece. You really won't have to use it, but if you want to look at it graphically, you can. So what we're going to do when we look at a piecewise function is we're really going to learn how to evaluate it. So when I look at this first problem, I have 3 different pieces. So I have my first piece here. That is when x is less than -2, less than or equal to. For this function, it's when x is greater than -2, but less than or equal to 3. And then for this function, it's when x is greater than 3. So again, if you want to look at it in Desmos, go look at it in Desmos. But what you're really doing is you're going to figure out which domain it fits into to figure out which function you're going to plug it into. So when I look at this, I have an input value of -4, okay? So when I come over here to my graph, -4 is going to be less than -2. So I know that I'm going to plug in -4 to that first piece. So I'm going to come over here. I'm going to say 2 times -4 plus 8. And you can plug this into Desmos to evaluate it if you want to. It's completely up to you if you want to have that pulled up. Let's split screen that. Okay. So I can do 2 times -4 is -8 plus 8 is equal to 0. So if I input -4, I get out an output of 0. All right, so for my next one, if I look at my next problem, I'm going to have an input of 6. Well, 6 is greater than 3, so we're going to input that 6 into the third piece. So we're going to do the square root, and then we have 6 plus 3. Again, you can put that into Desmos if you want to, the square root of 6 plus 3, and that's going to give you 3. Well, 6 plus 3 is 9, and the square root of 9 is 3. So my output is 3. All right, so then we have our third piece. Now this one you really need to pay attention to. So my input is -2. Well, I have a -2 here and here. But the key is this one says that x is greater than -2. And this piece says that x is equal to -2. So the one we have to use is where it's going to be equal to -2, which is going to be the first piece. So we have 2 times -2 plus 8. So 2 times negative 2 is negative 4 plus 8, and that's going to give me positive 4 as my output. Okay, and the last one. So for the last one, we have 0 for our input, and 0 is going to fall between negative 2 and 3. So we're going to input 0 into the second one. So we have 0 squared plus minus 3. Well, 0 squared is 0. Minus 3 gives me an output of negative 3. Okay. All right. And that can happen with any set of piecewise functions. So right now, pause the video, see if you can do the second one with 8 and 10. All right, so as we continue on, this is 8, so that should have gone in the third piece. Okay, so if you said 8 minus 2, and that's the absolute value, so 8 minus 2 is 6, absolute value of 6 is going to be 6. All right, then we have 0. 0 is less than 1, so that's going in the first one. So we have 2 times 0 cubed minus 1. Well, 0 cubed is still 0, times 2 is 0, which gives me an output of negative 1. Now, probably more than likely what you're going to be looking at are the next two types, where you have multiple evaluations that you're going to have to do on your EOC. So I really would break this up piece by piece to figure this out. So if you notice, you have your inputs, and then on the outside of that, you're multiplying by numbers. So when I'm looking at this one, I'm going to start with the input of 3. All right, so if I do the input of 3 here, then I'm looking at the third one. Well, I can't input 3 into the second one because there's no input, there's no x. So if I have one like this where it's just a single value, then that has to be 3. So this is going to be 2 times 3, because that's what we get as my output. And therefore, this is going to be 6. All right, now I'm going to do the second one. So as I'm doing the second one, I'm doing an input of 5. Well, this one equals 5, so I'm going to put it in the third one. All right, so I'm going to do it down here so I can have some room for the problems as I finish. So if I plug 5 in, so that's going to be the absolute value of 5 minus 2. Well, 5 minus 2 is 3, so my output is 3. So this is going to be minus 3. And then the last one that we have an input of negative 1, but then it's being multiplied by 3. So if I do an input of negative 1, that's going to be less than 1. So we're going to put it in the first one. All right, so I have 2 times negative 1 cubed minus 1. Well, negative 1 cubed is negative 1. Then we have negative 1 times 2 is negative 2, so this is going to be negative 3. Well, 3 times negative 3, that's going to give me minus 9. Or you can put plus negative 9 if that works for you. So we have 6 minus 3 is 3, plus negative 9, that's going to give me negative 6 as my final answer. All right, so I'm going to erase all my highlights up here and kind of help do the same thing for the last one. So now we're going to do negative 2, and we're multiplying by negative 1 after we're done. So negative 2 is going to go in the first one, so that's what we're going to do. So I have 2 times negative 2 cubed, and that's going to be minus 1. And again, you can put it in Desmos, that's not a problem. So we have negative 2 cubes, that's going to give me negative 8. And then negative 8 times 2 is going to be 16, and then 16 minus 1, or excuse me, negative 16 minus 1 is going to be negative 17. So we have negative 1 times negative 17 is going to give me positive 17. All right, so for the next one, we're going to put in negative 3. Negative 3 is also going to be less than negative 1, so we're going to put it in the same one for this one. All right, so I'm going to do the process over again. So I have negative 3. And since I've already got it typed into Desmos, I can just go ahead and come over here and change that. Put in a 3, and that gives me negative 55. But we're doing 2 times negative 55, which is going to be plus negative 110, plus 1. So then, of course, you're going to evaluate all of that together. So that's going to be 17 plus negative 10 plus 1. And my final answer is negative 92. All right. Now, those were all using the equations for the piecewise, but you can also do it graphically. So you can see I have 3 different pieces here. I have this piece, I have the second one, and the third one. But either way, all you're doing is you're going to be looking for where the value is asking you to evaluate the x. So this one's asking you to evaluate the x at positive 2. So at positive 2, I'm looking at an output value of negative 1. All right, so for the next one, I'm looking at negative 3. So if I'm looking at negative 3, now this one, I have negative 3, and I have an open circle, so that one's not going to work. We're going to have to go up to the next one. And I'm going to have to kind of estimate there, but it looks like it's about halfway, so this one would be 2.5. All right, and then we have a input value of negative 1. So if I have an input value of negative 1, I'm going to go to negative 1. And I see a couple of things happening here. So above it, I have an open circle, and below it, I have an open circle. There is nothing that is defined at negative 1. So this is actually undefined. There's not a y value that we get for that output. And then we come to negative 4. So if I look at negative 4, and I go up to my function here, I see that I have an output y value of positive 2. All right, so very similar. Pause the video and see if you can figure out f of 0, f of negative 4, f of negative 1. All right, so at f of 0, I got that I have an output of 2. And then for f of negative 4, I got an output of positive 1. And then for f of negative 1, I got an output of, so if I go up, there's an open circle, but I have to go down to the closed circle, which is going to give me an output of negative 2. All right, and then you can have a whole evaluation that you need to figure out. It works the same way as the equation. You just have to look at it graphically. All right, so if I'm looking at, so we have f of 3. So if I go to f of 3 and I go up, I can see the f of 3 is at 3. So we have 2 times 3, that's going to give me 6. And then the next one that I have is going to be f of negative 1. So if I go to negative 1, again, we figured out earlier that at negative 1, we have that same output of negative 2. So we have negative 5 times negative 2, which is going to give me positive 10. So when I put this together, I have 6 plus 10, which is going to give me 16. All right. I hope this helps you understand piecewise. Let me know if you have any questions.